Hello there, everybody. Welcome to the Independence Public Library's Science Time. As always, I am part-time scientist Mr. Alex, and I would like to wish you a happy summer reading because here at the Independence Public Library, we've started our summer reading program, and reading colors your world. That's the theme for our summer reading this year. If you haven't already, be sure to either drop by the library in person when we're open or visit our Independence Public Library's Facebook page in order to sign up for summer reading so that you could potentially win amazing, fun, awesome prizes just for doing the reading you were already going to do. But with that out of the way, let's do our first science time of summer reading. So for this one, it's going to be something really cool. We are going to make our own lava lamp using only household materials and a little bit of chemistry. So let's start off. As you can see right here, I've got a glass of vegetable oil that I poured straight from here. You're going to need vegetable oil. You're going to need a little water and ideally some food coloring to give the lava lamp a little pizzazz and make it colorful. And also, it's the theme of our summer reading. Reading colors your world. Let's get a little colorful. I chose red just because I think that looks cool. Explosive, like a volcano lava. That's what I think of when I think of lava lamps. And finally, you're going to need some Alka-Seltzer or some other similar, one of these anti-acid tablets. So what we're going to do is first you're going to take your glass and you're going to fill it about 2/3 of the way up with vegetable oil. Then, in a different cup, you're going to get a decent amount of water and you're going to color it with food coloring if you have that available. This works without coloring it in, but it's not as easy to see what's going on. You're just going to pour the water in here, drop a little bit of food coloring in, mix it all together, and there we go. And from this point, we're going to take our glass of oil and we're going to pour in some of our food coloring water. Not quite to the top, leave a little bit of space, but we're going to pour in just about enough so there's a little bit of space left. So let's start that. Okay, that's probably good. And if you can see that, there's little bubbles in the oil and water at the bottom, but they're not mixing together. And this is something that you've probably heard people bring up a lot. Water and oil don't mix. And there's a reason for that. It's because in chemistry, there's something that we call, we say that some materials are polar. In this case, water is polar. And what that means, essentially, is that one side has a positive charge, the other side has a negative charge. And like the saying goes, opposites attract. Positive charges like to meet up with negative charges and connect together. Positive charges don't want to connect to other positive charges, and negative charges don't want to connect to other negative charges because that would be boring. We don't want to all be exactly the same, and neither does chemistry. So the interesting thing here is water is a polar charged liquid. One side of a water molecule is positive, the other is negative. Oil is not polar. It does not have a difference of charge between it. It's the same charge all the way around. So water, finding that kind of boring, just kind of sticks to itself. One water molecule's positive side will connect to the negative side of another water molecule instead of connecting together with the oil. And that's why you get those little bubbles and you see that it doesn't mix. Even if you try to shake it around, it just kind of floats there and they separate. And water is also denser than oil, and we'll talk about density a bit later, so it actually sinks below it once they finally get all settled. But that's part one. The reason they won't mix: water is polar, oil is not. That's not good for mixing. Now let's get to part two. So we've got our oil and water mixture. Now it's time for the Alka-Seltzer to come into play. So we're going to open this up, And we're going to take out an Alka-Seltzer tablet. And I think you know what's going to happen. We're going to break this into little chunks, and we're going to put it into here, and it's going to start bubbling. So let's give it a go. I recommend, like I said before, leave a little space at the top so it doesn't overflow, and start small, little chunks at a time. Make sure that wherever you're at, you can afford to get it a little wet, just in case something goes wrong. So let's begin. Ooh, we've got some bubbles going. It sank all the way down to the bottom. Look at that. Let's put a little bit more in. Let's see what happens. Wow, that's just neat, isn't it? It looks just like a lava lamp. A little bit more. And you know what, why not? A little bit more too. As long as it's not overflowing, we are okay. Look at that go, look at that go. It's just bubbling all over the place. Isn't that cool? The reason it's doing that is because the Alka-Seltzer is water soluble, which just means that it can dissolve in water. So it will dissolve into it, and in this case, it ends up bubbling as a result. It doesn't really react with the oil at all, so it just kind of passes through. But the Alka-Seltzer touches the water, and it starts reacting with it, and then it creates these little bubbles that pushes the water up until it gets to the top. And like we said before, it can't mix into the oil, so it just kind of exists as these little red water bubbles that pass through the oil and head upwards. As you can see now, it's cooling down since the reactions have already taken place. But yeah, isn't that neat? Very, very cool stuff. And it's not really much of a lamp without a light source, but the cool thing about it is if you have a flashlight you can hold up to this, you can have it glow. You can have it glow just like a lava lamp. And you would be amazed at how similar it looks. And in fact, I'll show you in just a minute. But as for that, I'm glad that you were able to tune in to this first Science Time of summer reading. Remember, reading colors your world. Be sure to sign up for our summer reading program if you haven't already. It's going on until the 14th of August, so you've got plenty of time if you get started now. But even if it gets late into the summer, don't worry. You can still sign up until that last day and try to get as much reading done so you can win as many prizes as possible. Once again, I am part-time scientist Mr. Alex, and I hope that you have a fantastic rest of your day. Happy summer reading, everybody.